Ladies and gentlemen, we will now continue to the main agenda for today's event, visiting lecture with the theme of current information technology that will be delivered by our honorable speaker, Professor Gasan Bidun. He is a professor of information systems, University of Technology, Sydney, Australia. For this section, I would like to give attention to all the participants who joining us virtually for these following matters. First, please open your camera and turn off your microphone during this presentation. If you have any question, please write it down to the Q&A section with format your name, _institution, and then your question, or you can ask directly by using the raise hand feature. It is expected that all participants to fill the attendance form with link that will be shared on chat box at the end of this event. We will share a link for attendance form later. Okay, ladies and gentlemen, this session will be moderated by Mrs. Mayang Angling Sari Putri, SST MCOM. Now I would like to invite Mrs. Mayang and Professor Gasan to guide us through an insightful lecture. Mrs. Mayang, if you may guide this visiting lecture, this session is yours.
Okay. Good morning, everyone. Welcome to the visiting lecture on current information and technology. My name is Mayang Ningsari Putri. I'm the lecturer in Information Systems Study Program, Fakultas of Sains and Tekhnologi, Universitas Terbuka. I'm happy to be your moderator today. Today we are very lucky to have the special guest, Professor Gasan Bidun. Professor Gasan Bidun is the lecturer in University of Technology, Sydney, in Australia. Professor Bidun is the specialist in information system, and he is here now to share his knowledge with us. Before we start, let me explain how the session will go. First, Professor Gasan Bidun will give his lecture. After that, we will have the question and answer sessions, and please feel free to type your question in the chat during the lecture. We will choose the sum of them and answer the later. Or if any audience member have the question, please raise your hand and ask the question. Thank you very much, Professor Bidun, for being here today. And we are very excited to hear your lecture. Now, Professor Bidun, please start your presentation. The time is yours.
It's been such a wonderful opportunity to be in Indonesia, in Medan, and I've seen stuff that I'm so amazed at the beauty of the country and the hospitality and the warmth of the people. So thank you very much for creating this opportunity for me to be here and enjoy the Indonesian culture and education and learn about the education system in Indonesia. I'm a professor of information systems at the University of Technology of Sydney, and I'm also the head of the information systems discipline at UTS. And I heard that there are 24,000 students studying information systems at UT. We don't have that at UTS. We have about 1% of that studying information systems. So our discipline would probably have about 200-300 students studying information systems, also in the information systems discipline. I did my PhD many years ago, 25 years ago almost, and my area of expertise is knowledge engineering. So knowledge engineering is essentially looking at the world around us and trying and describe the world in a way that the computer can access that description, that representation of the world. And that's a common thing we do all the time, but often it's not done systematically. So my expertise in research is really conceptual modeling, looking at the world, taking concepts in a way that humans can understand and talking about the relationships between these concepts and putting all this into the computer so that you can use algorithms and you can use AI and you can do rule-based systems over that description. You can ask questions. So I've been doing this pretty much since, the mid-90s, way before AI came along. Well, I knew about AI. My PhD was on AI. Many people talk about AI these days as if it just happened the last 5 years. But really, AI started before computer science almost. AI started in the late 40s. So as a PhD students, we used to go through the history of AI from the 50s to the 90s. But now what happened in AI recently is that computers got much faster, and we can do a lot more things that we couldn't dream of doing, say, 20 years ago. So back to my research agenda and what I've been doing over the past 10, 15 years in the information systems discipline is I've been focusing on the specific types of problems, human problems, where you have to access knowledge sources. So, and by access knowledge sources, I mean before you execute whatever is it that you want to do as a human being, you have to reach out and get knowledge. So students, of course, they do this all the time, but so do many other people in many other activities. So I've done a lot of work in disaster management, for example. So in disaster management, when a disaster strikes, you have people who are involved in responding to the disaster. And it's their job to know how to respond, and they access things like disaster management plans, and they also have to know who's in charge of what. That's just to give you one example. Online teaching, obviously we all use to online teaching, and we all have to access lectures. We have to know who's the tutor, who's the lecturer, who's the coordinator, and depending on what we do, sometimes we have to know who's the dean and so forth. In software development, if you look at the software developer and they've been tasked with that, $1 million software development project. You have a project manager. The project manager has to know what the development methodology is, what are the various roles of the software developers on the team. You have the systems analysts, you have the coders, you have the testers, so forth. So somebody has to know all these things, and these things often are reusable. So meaning that if you take a project manager and software developer, he's going to be reusing the same knowledge over and over again. If you take different software project managers, they're also going to be reusing the same knowledge over and over again. Now, the problem with reuse that I've been considering in my research, and when I say research, I mean my PhD students over the years and teaching assistants and postdocs, depending on the funding, is how do we maintain this reuse knowledge? So when people access some repository of knowledge, be it in disaster management, software development, it's not easy to access that knowledge, and sometimes the knowledge to access the knowledge is lost. So every time a project manager comes along to access a particular software development methodology, they have to figure out their way of accessing that knowledge. So some of the stuff that some of the challenges I look at in my research is how do we reuse this process knowledge quickly? And often you are faced with different situations, say as a project manager, or as a student, or as an online teacher, or as a disaster management practitioner, is that you see these various ways of doing things, but none of these various ways is applicable fully. So reuse often comes in the form of partial reuse. You only want to use that part of the project management technology, or you only want to reuse that part of the disaster management knowledge, or you only want to reuse as a student only those lecture slides from that subject. But ideally, you also want to be able to mix and match these various bits and pieces to address the challenge that you're looking at. So if you're a student and you want to learn something about web programming, you might find something relevant in the contents of this subject, something relevant in the contents of this subject, and so forth. And you want to be able to mix and match according to your interests. And as I said, this happens in disaster management, this happens in software development. in many human endeavors. So some of the challenges of so these are some of the challenges I've dealt with in my research, and by challenges I mean each one of these challenges I had a number of PhD students working on those single challenges. So one of the key observations of my research, if you like, is the premise of the hypothesis of my research agenda is, although that all these types of knowledges are different, disaster management is different to online learning, it's different to software development, it's different to procuring large infrastructure project, that's another area I worked in, or in energy planning. All these kinds of knowledge are different. But the observation that I guess my research is based on is that all these types of knowledge, you have humans around them, and what is constant or what is static between these different problems is that you have human roles, human stakeholders, and the description of these roles is the most steady element of all these domains. So if you take a disaster management plan, you would have certain roles in disaster management, like a local controller or people on the ground, and you can describe their roles very specifically. If you take, and those roles are steady, be it 30 years ago, perhaps 20 years in the future. Same thing with online teaching. We've always had lecturers, we've always had tutors, we've always had subject coordinators. So you've got human organizations that are steady across all these different domains. So which leads me, I guess, to the next part of the next slide. Next slide, please. That slide. Yeah, the one. Yeah, the next one. Yeah, the one after this one. Next. Perfect. Which takes me to my focus of my research within the knowledge reuse is what's called agent-based knowledge analysis. So from within artificial intelligence, there's a software engineering area within artificial intelligence called agent-oriented software engineering. And that area is 20 years old, so it's not super recent. And that area looks at systems analysis of distributed artificial intelligence systems. So it's a software development process for distributed artificial intelligence systems. Now, in distributed artificial intelligence systems, instead of people talking about class hierarchies and object-oriented programming, they talk about agent-oriented analysis. So you have things called agents, and these agents, so we are human agents, but in AI you have software agents, and agents sense their environment, they take sensory input and they produce effect on the environment, and they have tasks and so forth. So agent-based analysis is the central approach that discovered that it is really handy in trying to capture this organizational knowledge across these different domains. So I guess I'm trying to motivate why agent-based knowledge analysis is really a beautiful vehicle, really, to do knowledge reuse. Because the human organizations are steady, but knowledge changes. And if we focus on the human organization as the basis of knowledge retrieval, we can solve lots of these knowledge reuse problems, which is what I will be showing you in I guess, in this presentation. So to apply agent-based knowledge analysis retrieval across these complex domains, essentially we have a methodology where the first thing you need to do is you need to come up with an abstract knowledge that unifies the various sources. At Inondel, a couple of days ago, I shared with the audience an abstract representation of how do we personalize online access. How do we? So what is the personalization knowledge? So we came up with a small language for personalizing online resources. What I will show you in this lecture is a unification language for disaster management. So it's the same approach. So if you want to do software development knowledge reuse, it's important to come up with a language that describes these various software resources across different knowledge repositories. If you want to do the same in online resources, you come up with a unification language across these various online resources. So what I will show you is essentially this process, the first step of which is creating a unification language within the context of disaster management. And I'll show you how we use the stakeholder roles in context to retrieve the knowledge once we unified it. So the idea is you first have this unification language, and once you have the unification language, you can put the resources and you can access all these resources as a single repository. And once you have this single repository, then you can access that single repository using the organizational descriptions. And as I said, I've done some work similar to this in online learning systems, which is what I've talked about in Ondel. And I've also done some work in the space of farming. But I've done a lot of work in disaster management, and some of my students were actually Indonesian students. There's a Professor Dedi Anan, he's at University of Papua. I'm very proud of him. He became professor last year. He did his PhD with me in Australia. I think he finished in 2015. So some of this work was done with Professor Dedi, and I think many of you can go and visit him at the University of Papua, which I'm not sure where it is. I know it's in Indonesia, but well. I've done work with state emergency services and disaster management entities in Australia, like New South Wales, Victoria, and some farming companies, eLife, and some software companies like Surround Australia and Bridge Data. And I think on some of the stuff that I'm going to show you on these slides, there were 4 different PhD students. Dedi was one of them. There was another student, she's now I think senior lecturer at University of UTM in Malaysia, her name is Dr. Siti Aflan. There have been research assistants as funding permitted. So within the context of disaster management and this architecture system, the next slide. Yeah, thank you. So this system architecture could be used in disaster management, it could be used in online learning, it could be used in any type of knowledge that you are faced with challenges of knowledge reuse. And the idea is that you have a knowledge repository, in the case of disaster knowledge management, that's the yellow box on the right. And then you have different types of stakeholders that sit outside the system. So in the disaster management, there's local authority, emergency coordinators, researchers, or users monitoring what's going on. And all these users, they have different types of interactions with the system. So the knowledge that any one of these users needs would be completely different. But all that kind of knowledge would be sitting in the repository. Now, my research in knowledge engineering really is about creating that blue box on the left. And that blue box is like the gateway that enables different stakeholders to access that repository of knowledge. So what I will show you on the next few slides is how do we create that yellow box, and what does the blue box look like, which is the tunnel into the yellow box. And at the end of the presentation, towards the end, I'll talk about the implication of AI, modern AI, and what we are trying to do with modern AI to enhance these blue boxes and the yellow boxes. Next slide, please. So the blue box that unifies all the various knowledge is called the meta model. So it's a model about models. I mean, most of you here in information systems or computer science would have heard about models or stuff like UML, Unified Modeling Language, in object-oriented modeling. So above UML, there's if you like, you can think of UML as a meta model. So UML unifies all the various models of object-oriented models. So in this methodology that I'm showing you to knowledge reuse, you essentially create a UML equivalent to the domain that you want to work with. So if you want to work on disaster management, you create the UML equivalent for disaster management. If you want to work on personalization of